And I think we are live. Thank you everyone for joining the second workshop for Oraichain on DoraHacks IO for the AI DeFi Cook-Off Hackathon. My name is Jeff, and I'm super excited to be here today with Pham, one of the co-founders and DeFi lead at Oraichain, for an exciting workshop session on bridging EVM tokens to Oraichain and other networks. Before we dive deeper into the workshop, I would like to intro the hackathon, what it's about, and what our expectations are. The hackathon is a unique opportunity to bridge AI to Web3 and unleash creativity, not focused on one chain, but the entire ecosystem, with developers open to create AI models and mini apps tailored to IBC, EVM, Bitcoin, or any assets you can really think of. Oraichain's app chain will be an AI-powered home base and help improve the Web3 user experience. There's already some solid project submissions. However, if you haven't joined the hackathon yet, there's still time, and we really encourage you to do so on DoraHacks.io, as it's an exciting opportunity to participate with a 30K prize pool still up for grabs. Before we start the workshop, I want everyone to know that they're free to ask any questions in the chat. When we read them, we'll address them and answer them as best as we can. You could either ask the questions in the YouTube or Binance live chat. And before we jump into the technical workshop, Duck, if you would like to introduce yourself further, have any opening thoughts, what kind of builds you're expecting from the hackathon, please go ahead. The stage is yours.
Thank you, Jeff. Hi everyone. My name is Duke. I'm the co-founder and the tech lead of the DeFi team of Oraichain Labs. So I've been working on the DeFi field and the decentralized applications on Oraichain for quite a while now, maybe like more than 3 years, nearly 4 years now. And I'm really excited to be here on the live stream and in the workshop, so that I can introduce to you guys all of the technology that we are working on, so that you guys can understand more and can have a chance to hack it to build even greater applications. And I hope that we will have like a wonderful and meaningful workshop. And if you have any questions, feel free to ask me.
Thank you so much. Yeah, I think that was a great explanation. We're really excited, especially getting down into the nitty gritty for this technical workshop. So if you want to, get started with the presentation and explain, the technical portion of this workshop, we'd really appreciate. Thank you.
Sure. Okay. So I'm gonna get started. So the content of the workshop today, I'm going to focus mostly about the process of transferring one token from an EVM network to Oraichain and going back from Oraichain to the EVM network. I will go into the details of how you can look at the transactions on the explorers, and how you can identify what transaction belongs to what transaction. And then eventually my hope is that you will be able to, for example, build like an application that can automatically listen to events and transactions from the networks and then display them. Like you can connect the transactions together so that one rich transaction can be like combined or aggregated into like one single transaction, so that the users can see where the token is like currently located, or like when the process is finished, or like, for example, if a token is stuck somewhere, the user should know, right? So I'm going to walk you through the process. Okay, so first off is the EVM networks here, I mean, is the chains using the Ethereum virtual machine as core. For example, Ethereum, Binance Smart Chain, for example, and Oraichain is, of course, is an L1 blockchain network. So we use Cosmos SDK and Cosmos to build smart contracts. The key technology we focus on is the gravity bridge, which is forked from the gravity bridge repository. So we call it Orai Bridge, and we modify the repository and update to allow the network to support multiple EVM networks. So currently, Gravity Bridge only supports Ethereum, but on Oraichain and Orai Bridge, we are able to support multiple EVM networks like Binance Smart Chain, Tron, and maybe even more if you want. Yeah. So firstly, we need to identify, like, since for the EVM network, like Binance Smart Chain, we have BSC scan, right? And for Oraichain, we have our scan.orai.io. And for Orai Bridge, normally for normal users, they don't need to care about the Orai Bridge network, since the whole purpose of our feature is to have like a one-step transaction. So with just one transaction, user will receive the tokens from one end to another, like for example, from EVM to Oraichain. Right. So we need to get into the Explorer of Orai Bridge first. So I may have to switch the network in the screen sharing. Give me a second. Okay, here is it. So the user interface is just like a fork from the Orai scan, but mostly we only focus on the transaction itself, since we need to keep track of the transaction types. As you can see, we have some interesting transactions. As you can see, for example, message sent to Cosmos claim, or message execute IBC auto forwards, or message batch sent to Ethereum claim. So later on, you will know what these messages do and how to read them. Okay. Here's the example. Here's the example of the message sent to Cosmos claim. Here's the information, the amount, and how we annotate the tokens and stuff. Okay, and here's the message batch sent to Ethereum claim. It doesn't have much, but yeah. Okay, let's switch back to the slide. Maybe I can just share the entire screen. So that should do. Let me close off some tabs and then the screen. Yeah, this should be easier. Okay, back to my slides. I'm not sure if you can see it. Do it this way. Okay, so here's the diagram that I drew to view the entire process of reaching a token from EVM to Oraichain. Firstly, the user will trigger the function send to Cosmos on a contract called Oraichain contract that will lock the EVM tokens inside that contract, and then it will emit a send to Cosmos event. And the Oraichain orchestrators and relayers will catch it, and then will forward and create a submit and vote message. Also, they validate the transaction as well. So the network, if there are a lot of orchestrators to validate the message, then the transaction will be like guaranteed to be quite safe. And then after the validators have submitted their votes, then Oraichain will calculate and will validate the vote based on the voting power. And if the transaction is valid, then the network will automatically create the new pending IBC auto forward, and the orchestrators will also listen to the IBC transfer message and forward it to the IBC relayers, and then the IBC relayer will create a new IBC will actually relay the IBC transfer message. And then to Oraichain, the IBC wasn't smart contract will receive the funds and then will process the message from the IBC send message, particularly the memo field of the IBC. If you already know how IBC works, right? In the IBC send message, there should be like an optional memo field. So we use that to analyze, pass, and redirect the tokens to the right destination. So it is the flow from EVM to Oraichain. Now let's take a look by actually using the application itself. So I'm going to try to bridge some Orai to USDT on Oraichain. Let's swap one Orai. Okay, I must approve the BEP20 token, since the contract needs to forward the transaction and forward the token. And here we go. Here's the send to message, or send to Cosmos. Sorry. And here's the hex. I will show you the transaction hash very soon. Confirm. Okay. So let's go to BSC scan and let's wait for a bit. Here's a proof message. Where is it? Maybe BSC scan is slow. Here we go. Here's the send to Cosmos. So as you can see, my wallet interacts with this contract. Let's take it slow and one by one. So the input data that the application sends to the contract are here. The first one is the token address, which is the Aura address, right? Yeah, as expected. The destination, it is quite tricky because we came up with a way to identify where the token and what address should be the receiver. So the first part before the colon here is the initial destination, which is here's the Aura address. Here's the channel one. Channel one is the IBC channel of Aura bridge, which connects to the IBC WASM channel on Oraichain. And after that is the destination. Here's the receiver. Here's the final receiver of the token, and this is the actual CW20 of the USDT token on Oraichain. So it is how we identify the destination and the receiver of the token. But you don't really need to worry about this much because it's quite complex. So I'm going to keep it as simple as possible. Here's the amount, which is 10 power 18 as far as I remember. Yeah. And let's take a quick look at this contract. So what does this contract do? So this contract is the Aura bridge contract. Apparently we maybe in the future we will upload the entire source code, but it is currently public, so you can view it here. Here. So we fork it completely from Gravity Bridge. So here's the entire contract. And we also have a proxy contract to handle cases like bridging from native ETH or native BNB, for example. And here's the source code for it. Let me see, proxy. Yeah, here's it. So the source code is also public. You can take a look at it or you want. Here's the bridge contract. So it is the proxy contract which will internally call the Gravity Bridge or Aura Bridge contract, and it basically just wraps some of the functions that we want to make the transaction in one step. For example, when bridging from ETH, we can firstly send some native ETH to the contract first, and then it will automatically swap with the wrapped ETH, and then if the destination is empty, so we will send the token to the sender, or if the destination is not empty, we will call the send to coast mode function. Here's the send to coast mode one. Yeah, it's gravity bridge contract send to coast mode. So that's about it for the contract. I believe that if you want to truly understand how the contract works, you should read it carefully. So I hope that this live stream is recorded. So if you want, you can go back to where I showed you the link, and then you can view this source code and deep dive into it. Okay. After sending to coast mode, there is one field that I want you to notice, to take note. When you look at the logs, you can see on the event there is an event nonce here. So what does this do? Basically, the event nonce is a way to make sure that users cannot double spend what they already have. So after each send to coast mode transaction, the event nonce will increase, and on both sides, on the EVM side and on the Oraichain side, there will be two different nonces, but they are completely synchronized, and the gravity bridge team has already made sure that the nonces are handled properly. So we only need to take note of this so that we can follow what transaction is on the Oraichain bridge side that matches this transaction on the Binance Smart Chain side, for example. Yeah. Let's see. Okay, so we should expect the send to coast mode transaction to be on this side. And as you can see, we sent this transaction 8 minutes ago, right? Now, 8 minutes ago, over here, we also have a bunch of transactions coming up. So as of now, we have 4 validators on this network. So all 4 validators need to create a vote message, which is here, which is message sent to coast mode claim, so that the Oraichain bridge network can validate the bridge transaction. Here's the orchestrator, and if you take a look on the LCD, you can have better insight on what is happening. Let's see his event claim. Yeah, so you can see here the event nonce is 54406. What about this one? Yeah, it is the same, right? 54406. So the only way that you can link these two transactions are the nonces, so that they can help you like visualize how the tokens go and how one single step transaction is executed. Okay, then go back to the scan, and then after finishing the voting process, the transaction is valid. So the network created a pending IBC auto forward, and one of the orchestrator caught it and created this message execute IBC auto forward. So let's take a look in detail on LCD. So as you can see, here's the nonce still 54406, right? And for this transaction, it creates an IBC transfer here. So it is the send packet, which is the IBC send packet. And as you can see, we use the memo field to identify the destination. So basically, this is the receiver and the destination token. And for this transaction, to keep track of the following transaction on Oraichain, for IBC, they use packet sequence. So the packet sequence is 11928, right? So let's go to scan. Let's go to my wallet. And we have one message received packet here 11 minutes ago. That looks about right. Where's the packet sequence? Here you go, 11928. That's the same packet sequence on Oraichain. So since I already swap Orai to USDT on Oraichain from BSC to Oraichain, this transaction is the last transaction because there is no need for the protocol to redirect the token to any other chains, but we can still create a new transaction to, for example, swap from Orai from BSC to, for example, USDC on Ethereum, for example. We can also do that, but the tracing process will be more complicated. Okay, so I just explained in detail and in technical terms how to keep track from a token sending from EVM to Oraichain according to this diagram. Now let's move on to so on my slides here, I wrote down some of the key unique IDs. Here's the event nonce for message IB auto forward nonce, and then for IBC packet, it is the packet sequence. Okay, so what about the reverse direction from Oraichain to EVM? So this one is a bit more complicated, because on Orai bridge we forgot, in the gravity bridge also forgot to list out all of the unique transaction IDs when the tokens are on Orai bridge. So basically, okay, I'm getting ahead of myself. Let's explain this one first. Firstly, on Oraichain, we will trigger, the user will trigger a transfer to remote transaction on IBC volume contract. So let me show you where the contract is located. It is a Cosmos volume contract here. All the logic and the processing part on the Oraichain side is located here. So the function that we are talking about is here, this one. This one is the transfer to remote. You can also use a CW20 token to trigger this function as well. here. This is the execute receive, and it will also call this function. So this function is the key, and it will do a lot of things, but eventually it will create an IBC send packet, which will, in our case, which will send to the Ori bridge and eventually send to the Binance Smart Chain, for example. Okay, so let's try. Let's reverse the process. You can send this one. Approve. Okay, the transaction passed. And we can see it on Oraichain immediately. Yep. Yeah, here you can see this is the execute send, which will send the USDT token to the contract, and then will automatically call the transfer to remote. Since we are transferring USDT from Oraichain to Ori on BSC, we need to swap USDT to Ori first, and then we transfer Ori from Oraichain to BSC. Yeah. As you can see, here's the information of the transaction. The memo here is the destination of basically the receiver on the BSC side, and we denote ORIB, which is for the BSC network. For other networks like Ethereum or Tron, we have different prefixes. For Ethereum mainnet, we denote it as ETH mainnet, like this one. But let's focus on the BSC case for simplicity. And here's the remote address. So this address will be the address that is on Ori bridge. So let's move on to Ori bridge. According to the diagram, after the transaction, it will forward the transaction to the Ori bridge network through the IBC message transfer. Okay. Yeah. So as you can see, we have a message received packet 2 minutes ago. Since it is an IBC message, we can again match the packet sequence, which is no problem. But the next part is more complicated because we did not send enough information so that we can keep track of it easily. So after receiving the packet, the Ori bridge relayer, so first the Ori bridge network will create an outgoing transaction ID. So this ID is unique and it is incremented every time there is a transaction sending out to the EVM network. So let's take a look at the transaction again. And you will see the transaction ID. It's really long because of the IBC packet. Let's see. So here's the outgoing TX ID and the nodes. So unfortunately, in the next transaction that I'm about to show you, there is no TX ID involved. So you will need if you want to fully track the transactions, you need to listen to the WebSocket events certified from the WebSocket endpoint, and you will get this TX ID, and then before the request batch transaction, this transaction, you will collect all of the TX ID possible, and you store it. Maybe you store it in a list, for example. Since this request batch transaction will accumulate all of the pending TX IDs and then put them into a batch. And then afterwards, the transaction IDs will be removed. So there will be no trace left. That is why I ask you to put the TX IDs into a list so that you can keep track of it. Let's take a look at the request batch, and you will see there's no trace on yeah. So this nonce is a completely different nonce. It is the batch nonce. It's completely different from the TX ID that I just showed you. But basically, in the source code itself, they are included. So yeah, you will need to include it somehow. In the future, maybe in our next Oraichain release, we will add the TX IDs in the Cosmos SDK event or in the module events. But right now, there's no way other than counting all the TX IDs before the request batch message is sent. So here are the confirm batch. So these are basically similar to what we saw with the message sent to Cosmos Claim. This message confirm batch are from the orchestrators or the network validators to confirm that this batch is valid. So after the network collects all for or enough for confirm batch, the orchestrator the Oraichain relayer will submit a submit batch message onto the Gravity contract on EVM, and this message will unlock the same amount of tokens that the user requests from the Oraichain side, and after that, the users will be able to receive the fund. Let's take a look at the contract. Check. Gravity bridge. So solidity, yeah. Contract, gravity. Let's see, submit batch. Yeah. This function can be called by anyone, as long as that person submits the correct and valid parameters. So there's no way that a person can fake or bypass this array of signatures, since these are the signatures from from the validators. So unless you have their keys, there's no way you can create these signatures. And after submitting the batch, here the token will send a transfer message to the. Oh, so this one is the fee. Currently, there's no fee. Here, we transfer to the destination and with the amount. Am I looking at the right transfer? Yeah, I think so. Yeah, this one. So this one is a sender. So this one is used to pay the to pay the relayer. Okay. Yeah, and after that there is some cleanup going on. The message batch sent to each claim. This one is to make sure that that there is no double spending on the OI bridge side, because there's no way the OI bridge network can know when the transaction on the BSC sky is executed, right? So after the execution of the transaction on the BSC side, the orchestrators will need to confirm it and to update the confirmation on OI bridge so that the transaction is finalized. Yeah, here's the batch nonce that we just mentioned, and let's take a look at the receiving transaction on BSC scan. Where is it? Not this one. I think it is not this one, but somehow on BSC it doesn't show anything. It is really slow. So let's see another transaction. Sorry about that. So for this transaction, BSC scan seems to not be able to identify the input. So we can just only view the logs here. So the event nonce now is 5. First one is 53792. Oh no! So this one is sent to cost mode. That's not it. This looks weird. Let me see. Yeah, so this one is the submit batch here. Oh, nice. So we got it. So we got this one, submit batch. Let's take a look at the log. Here, so it is the event nonce right here, 54407. So if you take a look, the request batch, right? Yeah, so here's the batch nonce. I'm sorry. Yeah, so here's the batch nonce, which is 27076. And over here, as you can see, yeah, here's the batch nonce. So the message batch sent to each claim is to confirm that the transaction is finalized. Yeah, and that is for the Oraichain to EVM one way one step transaction. Yeah, and we have gone through the technical terms and the process of bridging between EVM and Oraichain. So what's next? You can surely build a decentralized application to visualize EVM, the process of bridging tokens between EVM and Oraichain, and maybe you can notify when something goes wrong, like when like a transaction is stuck somewhere, or there is a token not being relayed properly, for example. And also you can look further and understand also how we can do, like, for example, how we can do a one-step process between two EVM networks, for example, or we can also do a one-step transaction to Cosmos, to other Cosmos networks as well, for example, uh, Osmosis or Cosmos networks. Yeah, so you can take a look at those and maybe come up with some crazy, brilliant ideas for your for your hackathon. Yeah, and I think that's about it for my workshop. Thank you so much for listening. Feel free to have any questions. I'm here to welcome to, and I'd love to answer all of your questions. Thank you.
Thank you so much for giving us that entire walkthrough, and especially your time today. It was really comprehensive, informational. You showed us great examples of how to running down the transaction, gave us a technical rundown, and really went through the analysis of the code. I really hope it helps the developers and viewers get a deeper and better understanding of the contract code and the operational side as well. So I really appreciate that. I think it's very informational and will help a lot of the people out there. Previous to like what you were asking before, I just want to let you know that this live is going to be recorded and will be uploaded on YouTube. So the viewers are more than welcome to look back onto the video and kind of go explore the URLs that you were talking about to find the source code. Additionally, I believe it will be a great resource for the developers. So if you could, upload the links to the source code to your hackathon site as well,
Sure.
it would be really beneficial for everyone, to kind of centralize all the links for all the resources for anyone that wants to take a look at it. I think that would be great. Yeah, so I'm going to open the floor to any questions that we may have to any of the viewers that we currently are looking at. Yeah, so a question on my side that I have is, when we're developing, who's like the best person to reach out to? What's the best medium to reach out to for the builders and hackers who have these technical questions? Who should they reach out to?
Okay. They can reach out to me, of course, and our CTO as well. He's really helpful, and he has a lot of knowledge to share. So yeah, and also I believe that maybe let me ask my team. Maybe some of them are available when the hackathon starts, but I'm not sure. Yeah.
Yeah, definitely. Yeah, so feel free to contact them personally. I think you could reach out to me as well. Also, like on our DoraHacks websites, we have support lines. So feel free to reach out if you have any questions, and we could connect you to the right person to help discuss further. Additionally, another question that I have for you is, what is like the one important thing that people who are watching, what should they take from this workshop?
Okay, that is a good question. I feel like they should like firstly, they should try the features first, like using the Oraichain application. Try sending some tokens back and forth, and then they will need to look at the explorers and all the transactions and analyze all of those information, and then maybe they need to like try to connect all the dots like I showed on the workshop. And yeah, I think that after that they will like have a better and fully understanding of how the process works. Yeah.
Yeah, awesome. Thank you so much for giving that answer. Additionally, I saw at the end of your presentation, you gave great examples of, some dApps that can be built, some examples. So if you're watching this, I think, you should really take that into consideration and perhaps like integrate that into your hackathon builds. I think those are great ideas. So on that theme and on that idea, what are you looking forward to seeing from the hackathon? Any more further examples that you can give out? Any other themes that you can share with us?
Yeah, right now, based on my workshop and our CTOs, we are expecting to have crazy ideas about the apps. Like I mentioned, like maybe like routing the app, for example, or if someone is like really strong in technical, they can also contribute into the core blockchain, and then they can contribute to more features on the bridge network. Maybe like maybe we can have some applications to connect with other like non-EVM network as well, like Solana or Polkadot, for example. Yeah, that can be great, right?
Yeah, that would be
Yeah.
definitely some amazing opportunities. Yeah, like you said, and especially at the end of the presentation, once again, you gave out great ideas and things that a developer should really take into consideration. So yeah, I think the workshop is great, very informational. I really appreciate your time. I want to thank everyone in the audience for joining us in the second workshop for Oraichain with DoraHacks. If there's no further questions, I kind of want to end and give the floor again to Pham before any closing remarks that you would like to say before we head out.
Yeah. Firstly, thank you, Jeff, for hosting this amazing workshop, and thank you for having me. So and thank you for the audience for listening to my workshop, and hopefully that we will have like a very successful hackathon.
Yeah, I'm really looking forward to all the builds that are going to come through it. Once again, thank you so much for your time. I really hope it was informative for everyone, and I look forward to seeing all your submissions today. Awesome. Thank you so much.
Okay. Thank you.
All right. Bye-bye.
Bye.
Bye.